Hi guys, I'm going to demonstrate real quick some of the tools I've been working on for the purpose of streamlining the field layout of concrete forms. Kind of goal being to generate reports of what's needed, communicate the design, how to build the forms, and get feedback on adjustments to that design, the form design, and then translate that into a material list of forms that we need to make sure that we have what we need when we need it, and to some degree not waste a lot of time moving forms around that we don't need. So that's kind of the goal. I put together a simple foundation for the purpose of this demonstration. I'm going to start with the CAD platform I'm working on is TurboCAD Platform, and what I have is what they provide is this platform for scripting that will generate a parametric part. Now, parametric part just means that it's driven by variables. In this case, it's a concrete form or an assembly of concrete forms. This particular one, the way it's set up now, is a corner, so it includes an outside corner, 1 inch by 1 inch, outside corner part, and then two 10-inch panel parts, and then an inside corner part that are all combined to create this parametric assembly. I'm just going to kind of skim through. If I change that, just changing this variable, that's the parameter, to a T, becomes a T shape cap on the end of a wall or a pier, and then a 4-inch panel, which means it's actually two 4-inch panels that create the wall, the concrete form, all the way through 24-inch for the purpose of this tool. Some other variables that we may get into. Try to keep it simple, versatile, and use it for its purpose. It's a tool. It doesn't do everything, but work it to the best of its purpose for what I'm trying to accomplish. So how I'm going to start it out is I'm going to go around, I'm going to hit the corners, the T's, any caps, work my way through, and then fill in between with full panels. So as I get started, I'm going to try to, I've got my thickness of the wall. In this case, it's an 8-inch concrete wall. I'm going to set the height for the main part of this building at using 54-inch panels, forms, and then I'm going to call this a porch. We'll use 48-inch panels, the forms, and then we've got two 54-inch piers out here. And so I've set it up the way I'd like to start. And now I pull up it's a modification. Bigaccrete is who I originally built a lot of this tool for, um, but a lot of it I was able to repurpose, patch together uh, to make it work. Now it's concrete form parts, and instead of Bigaccrete pieces. Um, so basically, what I'm going to be tackling here is I start with a piece, and then what my next piece is going to be is what my selection is here. And I'll work my way up the wall using full panels, which will be out of this list. And then the orientation. How I have it set up for orientation is starting, call this on the left side of the building, plan view. Orientation 1 is for going up the left side. Orientation 2 is for going across to the right at the top. 3 clockwise right around the building. Orientation 4 is across the bottom. So I'm going to start for this purpose in the bottom left-hand corner. Moving it close, and it's a copy now. It's a copy leaving the original in that corner. Change this. I need it to be a T. Right away, I want to make sure my T thickness, which is the leg that extends. Let's take a look at this from plan view. The leg that extends, the base of the T, maybe would be a way of describing it. Change that to 8 inches as well. It changes my panel so that you have an 8-inch wall, the base of the T, 4-inch inside corner, 4-inch inside corner. And drop this into its location. I'm going to move clockwise right around the 54-inch perimeter. Again, dropping it nearby, modifying it to a corner. And my orientation again is clockwise. So now orientation 2. And orientation is important for how one concrete form locks into the next. And so rather than just rotating, flipping this one individual component, I'm going to use the parameter of orientation to change this same piece. It's still a corner for an 8-inch wall and 54 inches tall, but I'm going to use this orientation parameter to accomplish the specific piece that I'm looking for. In this case, I'm again copying it. Change this to a T. Check my parameters, 8-inch, 8-inch, 54. Make sure it's where I want it to be. Again, I'm hitting these kind of critical spots, the corners, T's, things where properties of the formed wall change. I'm using the orientation parameter to get the concrete form I'm looking for that particular corner. Making sure it's landing right where I'd like it to be. So now, just gonna check this. I can see my length is 16 inches. So I need my T thickness to be 16 inches. It gives me a 24-inch panel on the back of the T. Okay. Let's go up to the, we're going to call it porch. I'm going to change this to 48-inch panels in this area. And using my parameter for orientation. Systematically working clockwise around the building helps me to make less errors, maybe. It's worth a try anyway. Okay, so it appears I got some caps maybe I could drop in there. I'll go ahead and do that. You know what? I'll make that part of the wall assembly. As we're doing the wall, as we're doing the panels, the panel kind of naturally. The idea, as I was building the production documentation utility, was to make it so that as you come to an end of a wall, you can go directly to a corner or to cap it. So we'll save the caps of the ends here. See how that plays into that strategy. So we're ready to start filling in. I go right to a 24-inch, and my up the left-hand side is the number 1 orientation. I'll go ahead and get it started. Alright. Once I get it started right, make sure my numbers are good. Should be ready to buzz right up this wall. So as I come to this T, now I'm going to keep going with the 24-inch. And then make an estimate. 10 inches, a little bit short. Bump it up to 12 inches. And now, top, you can see that the 12-inch panel intersects with the, what in this case I'm calling a T panel, or T assembly. this up. Always trying to utilize 24-inch. It's by far what the majority of our panels are. By far, we have more 24-inch panels than any other. So here's assembles quickest this way also. Again, come to the corner. Drop this one back. See that it needs to be a 16. Again, I'm going to use my orientation, changing it to orientation 2. As I get to the back to the production documentation utility, got to make sure that I remember to change that orientation to 2 as well. And I'm tackling this with my own method. What it's going to do, though, is give us a kind of a living document that we can discuss. The guys in the field can look at it and say, hey, we want to build this differently. We want to put our ties in a different arrangement. We want to put our 16-inch. This is going to take a 16-inch panel. We want to put that right near this T for whatever reason. And so we can assemble it, or if they want to break up the 224s into 3 panels for whatever reason, we can look at that and make sure that what we collect, what we put on the truck, what we deliver, most closely reflects what we intend to build. That's the goal. It's a tool. Use it as a tool. Change our orientation to 2. Across the top. Adjust that. To meet this T. Double checking the T, make sure it's the right width, because now's the time to catch it. If we need to make any adjustment that affects this panel and the way the others adjacent to it, what size they should be. Everything looks fine, it's going to continue. Orientation hasn't changed. Hey, you got it right. First try. So again, remembering to keep my orientation correct. Work my way down this wall. Ready to turn the corner again. Orientation 4. What I'm doing with this little yellow dot in TurboCAD, this is a reference. Just gives me the ability to make sure that I'm dropping this form part, this parametric part, precisely where it snaps then to the form where I'm snapping right now is the inside corner of the previous, or the corner piece right before it. And so I'm selecting, just for technique explanation here, I'm selecting normally the inside or the outside of the form. Nice clean points to pick and drop parts to make sure that it's snapping directly to the point that I intend it to land. And what we don't see going on, which is really the power of computer-driven design, is the data that's being generated. I don't have a list that I'm checking off right now of how many panels of different sizes and what this assembly includes as far as an outside corner and inside corner, the different size panels involved with that assembly or this T. Instead, I'm working my way through methodically in a way that I'm minimizing error and maximizing proficiency in the field, letting the computer keep track of the data. That's the goal. Here we are, back where we started. Okay. Now what I'll do, let's pick this one up. If there are major changes, kind of the goal of the design of the tool was to give the operator the ability to, if I'm working in an area where these panels are very different than panels right beside it or in another area, I can make all my adjustments and then use those panels as the kind of template for that area, and making it, the goal then being to make it easy to multiply those parameters for each panel. In this case, I just need to make sure that I change this panel back to a 48-inch 4-footer. Wall thickness is the same, everything looks fine. Back to 24-inch. Again, I'm going across the bottom. Use my orientation. So back to the beginning, kind of, be a way to look at it. Going from the bottom left-hand corner up, from plan view. Take a look back at this. So I'm going to be in orientation 1. show you my orientation right here as well. Again. And I included these markers just as kind of a red flag, and also it's a communication device for discussing the design, the form design. But I can, as I'm working, I can just double check. Yep, I'm working with 48-inch tall, and I want to adjust this to a 24-inch. Just methodically going clockwise around the design. So if I knew that I wanted to change this next panel to say a 14-inch for some reason, I can go ahead and do that from the PDU, Production Documentation Utility. Trying to make it versatile without being too overwhelming. There's a lot that I can do here, a lot of data that could be generated. I could be counting down, could have an indication of how many panels we have in stock and counting down as we use them. I could have how many we've used count. There's a lot that can be done here. There's a lot. There's tools that I've built in the past for how to modify large parts of a project all at once. There are additional tools we can add, but try to keep it simple, versatile, usable, valuable, all those things. So we'll put a 14-inch panel in, and we'll change back to 24-inch, work our way to the corner. We'll pick a spot to demonstrate a shelf. If we want to make a drop in the footer, go down, then back up. This gives us the ability to discuss the form design. If guys in the field would like to build this drop from, we'll say, maybe this is 4'4", this is 3'10", top foundation, 12-footer. They want to build this in a different way, we can adjust the panel design. It gives the guy in the field change that to orientation 4 on me. Must have scrolled. Yeah, if I scroll a wheel, it changes the number of the orientation panel I'm about to generate. The idea is that the guys in the field have the opportunity to make a plan, adjust the design, the form design, and make sure that they get the panels that they need. And then when panels show up, we can put a few guys on. They can see the design, they know what's coming up ahead, and begin to get parts and pieces into place without a whole lot of direction. Make it easy for them to be successful. That's the goal. Here, I'll start with a panel that's nearby that I know is the similar dimensions and has similar parameters that have all been worked out for this area of the building. Make this a 16-inch wide. Change my orientation to 3 as if it's the wall's coming down the right-hand side. So it's a way of picturing it. And then I know my cap, I'm going to call a cap, is going to be right on the very end. So this panel only needs to come to where this pier ends. 12 inches works. So with that panel still selected, that assembly still selected, keep my orientation at 3, I'm going to select cap. And what it'll do, and by keeping this selected, my parameter is for a 16-inch thick wall. So a cap for a 16-inch thick wall is what I want to generate. So by having a 16-inch wall assembly selected, hopefully my correct orientation, it generates a cap for a 16-inch wall. So what I'm going to do, because I know I have another pier very similar to this, is select the 2 now. I'm not going to rebuild it. Just going to copy it. Because I know that it's similar out here, do something similar. What I'll do is I'll move this cap to the end. Set another one off to the side. Now, just kind of a rule of thumb, if my cap on one end is 3, which it was, orientation 3, my other orientation is going to be 1. It's going to be the opposite. It'll be the other odd number, basically. Looks fine. Okay. So I can kind of just quickly skim around. Everything looks like it's what I intend to build. This might go out for review, and it comes back, hey, you know, we gotta we got to put a drop in the footer over in this corner. Can you make sure we have the panels that we need? Perfect. Let's do it. Start here with this panel. Discuss. Oh, let's go around the corner. You know what? I want to break this half. I want to drop it just the way. Let's take a look and see what it takes. So now we want this one. We want to break it here so we have the ability to drop the footer. So this is orientation 2, going to the right across the top. I want a cat instead. I want a 12-inch. I have what I need. Alright. So we're going to drop it 2 feet, 24 inches. But we got to change our panel size. Make sure we're above top of wall. So in this case, out of the stock that we have, I'm selecting 8-foot panels for this area. Okay. Alright. So we made a drop in the footer, a drop in elevation, top of wall, have some piers. Alright. Now we gotta generate our report. So what I'm doing there is I'm breaking this apart into the individual pieces. The logic is gone now. When I select a part, it's an individual panel that has the data for that individual panel. How many? There's just one panel. How many ties are with that panel? The size, which is the width. Now we have the ability to run a report. Tells me how many of each of the different reports of each of the different panels that we're going to need for the project. So what it's doing is it's counting all the outside corners, all the inside corners, every individual piece now is broken apart. And its properties are quantified in that report. And if this was to be, if we're ready for this to be generated as a document for discussion, for the guys in the field to start building off of it, Dimensions can be added. Schedule of panels. So the guy loading the truck will know exactly how many panels to put on.